Hey, how's it going today? Hope you're doing well. I've got right here what we call Bob, or Breakout Box. Alright, and this plugs right into the DLC, or the data link connector, and it makes it a whole lot easier to kind of see what's going on in the DLC without having to stab everything. Again, if you wanted to plug in a scan tool, you could do that here. This is basically just a way for us to see what's going on in the DLC connector as far as powers and grounds and resistance goes. So today, this is kind of like the first step of like a communication error. If you have a communication issue, either the scan tool won't communicate with the vehicle, or there's several modules on the vehicle that won't communicate with the scan tool. We just want to make sure that there's some type of way to check the pulse of the communication system. So again, when we have this plugged in, we're just getting a quick reference as to what the communication lines look like. So just to refresh from what we did at the beginning of the semester, pins 4 and 5 are both ground. One is a scan tool ground and one is a chassis ground. Okay, we just want to make sure that those are in good shape. I've just got my meter set to ohms or resistance, and I just like to hit the squelch button or so that I'm not having to look directly at the meter. I can just see, I can hear, yeah, there's a connection. So I've got my nice lead here. I'll plug it into pin 4, and then I'm just going to go here and find ground on the chassis. Okay, so we got a good connection, about 1 ohm of resistance. Now I don't know if you can see this or not, but I've just probed one of the bolts directly to the frame of the vehicle. Okay, so now we've determined that pin 4 is good. Okay, we've determined that pin 5 is good. Alright, very good. So we at least know we have good grounds. Now, if this is the best meter you've got, great. It'll still work. But as far as trying to determine what's going on with the high-speed CAN, or as General Motors has their own name for it, but this is not the most precise or accurate way to measure what's going on. So the best tool to use is a scope, a lab scope, a picoscope, any type of lab scope, 1 channel, 2 channel, would be ideal so that you can actually see the waveform. And this is actually pretty slow as far as things go. So I'm going to plug one lead into pin 6, which is our CAN high. And again, this is on a 5-volt reference. And then I'm just going to hook up our leads here. And then I like to go min-max and then peak min-max. So now I've got that here. Alright, now I'm going to cycle the key on. Alright. So our max reading now is about 3.5 volts, which is awesome. Okay, so at least our CAN high circuit looks good. Okay, we're going to go to the min. Alright. Okay, so it should operate between 3.5 and 2.5 volts. So that looks great. Wonderful. We're going to go through here. We're just going to reset things. Min-max, peak min-max. And then we're going to go to pin 14, which is CAN low. So CAN is a 2-wire communication network. And we're just going to plug in here. So our max is 2.5. Let's see what our min is. Okay. Alright, so again, if you had a picoscope, you could see, or any other type of lab scope, you could see that it's not going, well, directly to 0 volts, but this should operate from 2.5 to 1.5 volts. So our max here is 2.5. Our min is 0.2 volts. But really, again, this kind of gives us just a quick reference as to what's going on. Then I'm just going to take the peak off, reset here, and then we're just going to check for battery voltage. Pin 16 here on the DLC is battery voltage. Okay, so right now we have 12.31 volts. All right, so at least for what we're doing, this is our quick check of the pulse, what's going on. 4 and 5 we have ground. Pin 6 looks like it's operating between 2.5 and 3.5. Pin 14, which is can low, operates from 2.5 to 1.5 volts. And then we have pin 16, which is our battery voltage. And this is the pin right here where the scan tool powers up from. Some scan tools have an internal battery, but most your cheaper aftermarket ones will just use power coming from the vehicle to power up the scan tool. Okay, so that's a pretty quick test of what's going on with the can just using our fluke meter. So hopefully this was helpful to you, and we'll move on to the next video so you can learn more. Second check that we can do using our digital volt-ohm meter. And this step we want to do first, disconnecting the battery. Okay. Now our two communication lines, our can high and our can low, pin 6 and 14, on the communication network there's two modules, generally one on either end of the network, that have what we call terminating resistors in them. Now each of these terminating resistors is a 120 ohm resistor. And when both those resistors are connected in parallel, the ohms, or the resistance, is cut in half. That's just kind of basic electrical theory. So what we're going to do is we're going to make sure that as far as a resistance test goes, that we have roughly that reading. Alright, so we put that up here, and we have, as you can see, 60.9 ohms of resistance, which is right where we want to be. So again, to finish off our checking the pulse, so to speak, 4 and 5 are grounded, 6 and 14 were operating up at 3.5, and then 14 was operating down at a 1.5, roughly. And then we had battery voltage at our pin 16 for the scan tool. Now we have validated that the integrity of the CAN bus is good because we have 60 ohms of resistance. Our third final test for this assignment is to disconnect one module that communicates on the CAN network and recheck pin 6 and 14. So my meter leads haven't moved at all. I disconnected that module, and voila, we have 119.2 or 0.3 ohms of resistance. So when we're reading the resistance value of one of those terminating resistors, that means we have an open on the circuit. Okay, so again, as far as that pulse check goes, we know what it should be. Now we see what it is when there's an open. And just for grins and giggles here, we're going to see what happens. Well, I'll plug that connector back in, and then we're going to see what happens when these are shorted together. Okay, so I got that connector back plugged in, and then we can see what happens. Okay, when we have a short which is together, we have 0 resistance. So again, hopefully that was helpful to you. Sorry, that's my phone. But hopefully that gave you at least some idea of what's going on, okay? So healthy is 60 ohms. If we have an open, it's 120 ohms. If we have some communication wires shorted together, we have 0 resistance.